Welcome to the Great Learning webinar, Supervised versus Unsupervised Learning in Machine Learning. So today we're going to talk about Supervised versus Unsupervised Learning in Machine Learning techniques. So this is about myself. So I have 15 years of experience in data science and IoT. I worked in domains such as banking and financial services, capital markets, corporate banking, retail, e-commerce, IME, healthcare for small period, etc. I worked for Fortune 500 companies and implemented larger data science engagements, data management engagements such as data lake and analytics and visualization engines. And I was part of the adjunct faculty for Sri Venkateswara College of Engineering, Chennai, Hindustan University, GKM College of Technology, Chennai. Also, I am a mentor for Great Lakes Institute of Management as well as GKM College of Technology, Chennai. So, the today's agenda that we're going to do is like we'll try to understand what is machine learning. We'll learn about machine learning techniques, difference between supervised and unsupervised learning, few examples of machine learning techniques, and industry-based case studies. And I have a video which I got it from YouTube about top 10 machine learning products or machine learning applications that's been used. So we'll just understand a little slowly. Okay. So I'll go a little slow and then try to understand what is data science. I'll just explain a little bit about data science, and then slowly go into machine learning. So what is data science? Is that it is fairly explained it in the terms of data as well as science. So over a decade, the companies, the Fortune 500 or most of the companies have collected data and then made a data warehouse platforms. Now they wanted to understand the patterns of data and then do analytics and improve their performance and improve their revenue and improve their profits. So that's where we are applying science or maybe tools and techniques that we are using currently. That forms a data science, right? So in terms of that, science why the term science comes into picture is that science meaning we are applying mathematics, we are applying statistics, we are applying any other sciences, right? Any other physics, chemistry, or whatever. Whatever things that we are applying into a data, which becomes converted into data science, right? So, over a couple of years, that term data science and analytics, has used very common in most of the industries, not only with IT, and most of the industries like manufacturing, other education institutions, logistical institutions, banking sector, retail sector, and most of the industries are started using data science practices. So now people are talking about machine learning and artificial intelligence, right? So what is machine learning? Now we just jump on to what is machine learning, right? So machine learning is about teaching computers and how to learn how to learn from the data, right? And take a decision based on it can be of anything. It can be of prediction, it can be of forecasting, or it can be of anything, right? So I'll give some basic examples later, but the high level explanation is that. So I am asking the computer to learn the program, to understand the data, and then bring the pattern out of it. From the pattern, I'm giving an insight to the senior management, and the senior management can take a decision as well as prediction based on that. So, I mean, hardly the definition is, machine learning is about teaching computers how to learn from the data to make a decision or a prediction. For a true machine learning, um, the computer must be able to learn and identify patterns without being explicitly programmed to, right? So it sits at the intersection of statistics and computer science. Yet, it can wear many different masks. You may also hear it labeled several other names or buzzwords such as we can say data science, we can say big data, we can say artificial intelligence, we can say predictive analytics, we can say any computational statistics and data, etc. Right. So, so in the normal day, which we hear about all these terms, right? So, all these terms are belongs to machine learning only. So maybe I can say data science is an extension. I mean, it's an extensive or like extended to machine learning and artificial intelligence, which we are automating certain things, and there is minimal intervention of program changes required to tune or change the algorithm to make the machine learning keeps working. Okay, one example. I hope everybody understands what is machine learning now. Nowadays we have, I mean, in data science we write programs. We write R programs. We use Python. Python to write programs, and we use plenty of packages. We use plenty of algorithms. We use algorithms such as logistic regression, linear regression, support vector machine, etc., etc. Right. So, so if I ask this program or computer to learn this about a data, this is the data, and then you have to understand this algorithm. So, computer understands the algorithm as well as the data, and the data will be having a labels. Okay, a labels in the sense, for example, it may have data might have apple, orange, banana, pineapple, or whatever. Right, so this is the labels, right? So the algorithm will be able to train it. Now the algorithm is trained in such a way that if there is an input comes in as apple, it can say apple. If the input comes in like pineapple, it can say it's pineapple. So something like the computer can able to understand on its own is a machine learning technique, right? I hope you understand that. I am moving on. Okay, so what are the types of machine learning? So there are broadly 4 types. Actually I have listed only 3. I don't want to confuse now, so I have listed only 3. But there are 4 types of machine learning techniques, or like machine learning high level. One is supervised, unsupervised, and there is a semi-supervised learning, and we have reinforcement learning. So these are all the broadly 4 types of machine learning techniques that we are using. So under supervised, we have prediction, we have classification, and regression as well. In the unsupervised, we have clustering, probability distribution estimation, finding association, dimension reduction. In reinforcement learning, we have decision making, like for example, I can say robots, chess machine, or such examples are reinforcement learning. So we'll take one example from supervised, unsupervised, and reinforcement learning. Then try to understand how it's been used, or how it's been giving an idea on supervised and unsupervised, right? So I'll take one example in supervised learning, right? I have given an example of apple, orange. So so this is the example, right? Example for that. So I have apple, orange, banana, pineapple, and different set of and then the types of fruits. So my algorithm says or understands that these are all the data parameters, with size and shape, and using the size and shape, like for example, if it is apple, it can say it is in red color or green color with this type of shape, right? Then it can be classified as apple. So if it is banana, the banana will be length in shape and it's yellow color or maybe light green color. You can say it is banana. So if it is orange, orange will have orange in shape, the color, the shape will be rounded, then it is orange. If it is pineapple, the outer layer will be little bit rough, then it has spines, etc. So then it will be classified as pineapple, and so on for various set of other fruits. So this is the program or labeling structure that I made for a program. Now the program in such a way that it's been understanding now. Now I just made the machine learning technique to understand with 100 of data. Meaning I have 100 of data. Under 100 of data, I am listing it and then labeling it. Okay. So my algorithm, I am getting a data of 101st data. So 101st data is apple, but it is in red in color. So based on the classification, right? So it is saying that it is red in color and it has this much size and etc. So I am saying that it is apple. So it is again classifying it, right? So that is apple. Similarly, orange comes in as a 102nd data, which is orange in color, and then it has a shape of rounded. Then it is classified as orange. Then there is a 103rd record, which comes as a pineapple, which is very rough outside, and it has spines, etc., and the leaves and etc. So it is classified as pineapple. So this is the broad example for a supervised learning. So under supervised learning, I can do prediction, I can do classification, or like classification meaning I'm splitting it according to based on the characteristics, based on the features of the data. So what is unsupervised learning, right? So unsupervised learning is there will not be any labels. There is no labels being proper labels being given, but the algorithm will be classifying or clustering it or grouping it, right? I'll take a situation of e-commerce platform, right? So the e-commerce platforms like Amazon or Flipkart or any of that, e-commerce platform for that matter, they'll do a grouping, grouping of customers. I hope everybody will be using those platforms. They do customer grouping. So based on the purchases, based on the interest, based on various sales purchases that you're making. Let's take between age group between 20 to 25. 25 of male will be purchasing a gadget or headphones or maybe power bank or maybe very good gadgets, right? So, and the age group between 25 to 30 will be buying something like a female could buy like a kurtis and makeup items, L18 or Maybelline, etc. Right? And mostly the married people between 30 to 35. So their purchase pattern could be of maybe a baby diapers or kids items, kids accessories, kids dress materials, etc. Right. So basically they'll be grouping them, clustering them into different buckets. Why they are doing a clustering or a grouping them to different buckets? So these groups will receive a personalized promotional messages, emailers, or maybe through any of the notifications, right? App-based notifications. So why they are sending it? So they would like to send these promotions to make sure that the age group between 22 to 25 buys more about gadgets, so they give more promotions. Like for example, hey Ramesh, there's a 30% off on a power bank. Would you like to buy, or something like that? Or the products which can be recommended in the underneath when you are doing when you are searching for a products. right? So they can group a like-minded or a similar type of customers and then cluster it into a bucket. They can send promotional messages, they can send promotional emails to get or to buy more and more sales so that it can improve their sales in the e-commerce platforms. So likewise, between 30 to 35 age of people where they are doing a clustering, they can send promotions based on kids items, right? So that is a example for unsupervised learning. So reinforcement learning is the robots or a chess machine, that computer chess machine, which has instant learning capabilities. If you play chess with chess in a computer, where based on the movement that it will learn and then make the movement accordingly. So mostly the reinforcement learning will be used in casinos and gaming options and things like that. Okay, so this is a high level of the workflow. So I'm moving to a left to right, top left to right. So this is my data training, text, documents, images, sounds, etc. It could be of anything. It could be of anything for that matter. So the input fields will have features meaning feature vectors, meaning any of the characteristics. Like for example, I said apple may have a characteristic of this shape and size. Orange could be of other a different shape and color, etc. And pineapple will have a different shape and color. So that is the feature vectors of the training data set. So the data set goes to preparing the features and then going to the machine learning algorithm. The algorithm again goes to a predictive model. Predictive model, I'm saying that is that any of the regression or a classification model, that I would say. So there are labels. So the labels on the left side, which I'm saying that this type of characteristics, meaning it goes to apple, it goes to orange, etc. So that again the labels also goes to machine learning algorithm and goes to predictive model. So predictive model, so I'm preparing a predictive model and keeping it ready, right? So suppose the new text or a document which comes into as an input, right? That is the new text, document, image and sound. So it may have features, it may have vectors also. Based on the features, it enters into the predictive model and it is saying that the expected label. So the expected label is apple. The expected label is pineapple. The expected label is banana, etc. So this is a supervised learning workflow. So what is the unsupervised learning workflow is that the same pattern, but there will not be any labels. There will not be any labels. I cannot say it is apple or orange. So that situation will not work here. So again, I can say cluster it into a different category. I can say the same e-commerce experience, right? So there is a customer data goes to different characteristics of features and vectors. The machine learning algorithm will be clustering it into different fields. For example, it has a cluster ID maybe. These are the age groups are between 25 to 30. That is one cluster ID. Age group between 21 to 25. Age group between 30 to 35. Age group between 35 to 40, etc. The new text, document or images or sounds which comes into a picture, which again goes to go through this predictive model. So that predictive model will be moving the data into different cluster IDs. So different cluster IDs meaning 25 to 30, 21 to 25, 30 to 35, 35 to 40. So that is the cluster ID. So I'm grouping those peoples into various clusters, right? So this is unsupervised learning. I have not made the reinforcement learning, as it may confuse you this time. So we are moving on to the learning techniques. So what are the learning techniques of supervised learning? So within supervised learning, so within the learning techniques of supervised learning, there are so many categories and techniques. So one is a linear classifier. So the linear classifier could be any of the numerical functions which I want to predict will be using a linear classifier. The other one is parametric classifier, or like parametric probabilistic functions. We can use algorithms such as naive Bayes, Gaussian discriminant analysis, hidden Markov model, probabilistic graphical model. And in non-parametric, we have instant-based functions. We are such as k nearest to mean, k nearest neighbor, kernel regression, kernel density estimation, local regression, etc. So in the non-metric, we have classification and regression models like decision tree, random forest, which can be used. In the aggregation, we have bagging and Hadoop boost and random forest, which we can use it for aggregation. So these are all the learning techniques. Don't confuse between learning techniques. Learning techniques are just an algorithms which we are trying to use. Based on the data, we can do a prediction, we can do or like classification based on the data. So under what criteria that we can do class or like which are, what are the types? The types are linear classifier, parametric, non-parametric, non-metric, and aggregation. So these are all the 5 learning techniques for a supervised learning. So under which, what are all the techniques that we have? Under parametric, we have naive Bayes, Gaussian, GDM methodology, HMO methodology, probabilistic graphical models, etc. So under non-parametric, we have KNN, kernel regression, kernel density estimation, and local regression, etc. So these are all the algorithms which I am going to use based on the data. So learning techniques for unsupervised learning is that clustering, K means clustering, spectral clustering, density estimation. We have Gaussian mixture model, graphical models, dimensionality reduction, principal component analysis, and factor analysis. Right. So these are all the basic algorithms, but these are all very few algorithms. Apart from that, there are a lot of algorithms available in statistics, which also can be used in any of the supervised and unsupervised learning methodologies. So this is at the high level difference between supervised and unsupervised learning. We'll go one by one. The first row, the input is in the form of raw data that's been labeled. Here in unsupervised, the input will not be labeled. The machine will be given a huge data sets as input, and then the machine will be classifying it differently. Second row, the machine needs to figure out the output on its own by identifying the patterns in the raw data provided to it. The machine is ready fed with a required feature set of classified between inputs. Divided into two types of problems. One is association and one is clustering. In unsupervised, divided into two types of problems. One is regression and classification. These are the high level, but internally we have so many learning techniques and patterns which is available based on the data that we can classify or like group it into or like move it into different segments. The supervised learning, we have k-means for clustering problems and a priori algorithms for association rules learning problems. Linear regression for regression problem, random forest for classification and regression problems, a support vector machine for classification problems can be used. Okay, we'll spend some time here how machine learning helps in various domains. So these are all very few domains that I have added since we don't have much time. We can take one or two case studies here and then try to understand how machine learning is helps in various domains. So on the top that I have classified into customer analytics, marketing analytics, operational analytics, store analytics, and digital media analytics. Right. So why I have classified into, rather than having a big domain, I have classified into a subdomain like customer analytics, marketing analytics, and so on. Most of the high-level domains will have these type of areas. If you take banking, you will have all these areas. If you take retail, you will have all these areas. If you have any other things, maybe you will have all these areas. Except store analytics, maybe store analytics will not be an apt word for different domains. Only in retail it can be used. Maybe in banking, we can say it as banking, where store can act as a bank. So that can be used. But most of the high-level domains are this customer analytics, marketing, operations, stores, and digital analytics. So I have classified into three areas where one is evolved, one is evolving, and aspiring. Right. So evolved is already there being used. Evolving is also they are trying to evolve and then bringing those analytics or like machine learning techniques into the field. And aspiring meaning it's a future, like they are still doing research and etc. Still there are a lot of improvements that can be made, which is again people are doing a research on that. Right. So just I'll pause for 2 minutes. Just go through this. We'll take one or two domains and then take a case study. I'll take a case study and then make you understand that case study into this machine learning. Okay. So I hope everybody have just looked into this domain-based machine learning technique. We can take one example and then try to understand a particular domain. Right. I'll take customer analytics, right? So in customer analytics, they evolved on our customer segmentation, propensity analytics, and loyalty. Evolving our lifetime value of the customer, influencer value of the customer, and household analytics. And aspired or augmented reality, real-time customer offer generation, etc. So these are all the areas that I have listed down. So customer segmentation. So we'll take some evolved one. So I'll take the same example, right? So Amazon or Flipkart or any of the e-commerce platforms are started using a customer segmentation. As the earlier example that I said, they are grouping their customers into various segments and they are promoting it or like recommending it. If you go to or like if you see a product in Amazon, they will say that people who also bought this type of products. So which means a similar kind of profile like me is also buying those products, so I am recommending it for you. So which again interests me, or Amazon is recommending it for me to buy those products as well, right? So that is a grouping of customers. Maybe a like-minded people like me will be getting the products, and using algorithms, they can give a recommendation engine and then recommend such products to the new customers. So that the customer segmentation is already there in the e-commerce platform. So lifetime of the customer. So lifetime value of the customer, right? I'll take a banking scenario here. So in a bank, you will you'll be opening an account, right? So you start with an account opening, and slowly, based on your so before that, I'll say about little bit about loyalty, right? So loyalty is that type of everybody will go to shopping centers like lifestyle or like Max Fashions, Landmark, and other big pantaloons and shopping centers, right? So they used to give a loyalty card. So the loyalty card is that when you purchase something, points will be added. So they'll be having a different categories such as gold, silver, platinum, diamond, etc. So that is the highest level of loyalty, right? So internally they have a grouping, right? So how loyal you are to the shops that you are purchasing, right? So so they will be so as a front end we know that there is a point being added, so we can redeem the point after some point of time, right? But at the back end they do a lot of loyalty and rewards analytics, where they want the customer from the silver band to move to a gold band, and a customer who is in the gold band should go to the platinum band, and the customer which has the platinum band should go to the next level band, right? So that is the goal of each of the store, where the customer has to spend more and then buy more products from the shops. So that is the loyalty. And now most of the Indian and then the foreign stores, the retail stores, everybody is having a loyalty and rewards program, which they started analyzing about the customer value. So moving on to the evolving is the lifetime value of the customer. So a customer, I want to keep a hold of the customer mostly throughout the life, right? I mean, for example, apt example is banking situation. So I'm holding an ICICI bank account, meaning I'm using ICICI bank. So after using of ICICI accounts, the savings account, they'll be issuing a credit card. Nowadays they're issuing a credit card instantly. So I'm trying to use a credit card from ICICI bank. Slowly, based on the purchase, and then after 4-5 years, they will say you are a privileged customer. They'll issue a privileged customer card. The privileged customer will have a different set of seating arrangements in the ICICI bank, and then if you go, they'll have a privileged customer care who will be addressing you, right? And then after some years, they'll say, why don't you avail a personal loan? So we offer a personal loan. The guy who gets a personal loan will keep extending the life value of bank, which for 3 more years. Then we'll say, why don't you avail a car loan? So car loans is also being issued based on the previous histories and etc. And being loyal, right? So he's loyal, so we are issuing a car loan to them. Post that, the bank is allowed him to avail a housing loan, which with 8% or 8.5% or whatever, right? So which means I am just locking the customer for another another 20 years, which means the customer will be there with the bank for more than 30 years. It's a huge benefit for the bank, and we can due to the interest rate and things like that, the bank will get more benefit out of it. So the aspiring is that augmented reality, so real-time customer offer generation. I think the real-time customer offer generation is already happening using IoT. IoT meaning Internet of Things, right? Augmented reality is that everybody use Lenskart and Lenskart.com, etc., where your face has been captured, and then face will be there in the iPad or mobile phones, right? So you can pick and choose the frames, and then the frames will be fitting in your face, and then you can see that whether it fits in properly or not, right? So that is again still evolving. Few companies are trying it out. Mostly in the retail sector, they are trying it out, and others like media and entertainment field is also trying it out. So Byju's is one of the augmented reality where people are very crazy about learning. The learning patterns are slightly increased by using the Byju software, right? So that is a good augmented reality case studies. And then the real-time customer offer is that where they are using IoT devices, to say. So this typical case study is a real-time scenario in US. Um, in the big stores like Walmart or Walgreens or whatever, right? So they'll be using IoT devices to get the MAC address of the mobile phones. If you switch on your Wi-Fi and a Bluetooth, it automatically picks and then asks for your and it gets a MAC address, and using the MAC address it gets the phone number. It gets a phone number, then it knows that it is Ramesh phone number, and Ramesh has a purchase pattern of this much, and I can send a real-time customer offers, personal customer offers for them. Like Ramesh, hey Ramesh, here, thank you for stepping into our store. We have a 40% off on kids items, and you can buy for it. So those type of items are still evolving, but it is a lot of research going on, and the accuracy is also pretty low. Where I could say the accuracy is around 60 to 70% of accuracy being maintained. But due to machine learning and deep learning steps coming in, more accuracies are being followed nowadays. So I'll take a pause here and then just go through the slide and then try to understand the slide. Maybe if you have any questions, we can take this up at the end. Okay, moving on to the case study. So this is a case study in retail. It's a Fortune 500 beverages company. So the beverage company has launched a IoT-based touch panel dispensing soft drinks. So the soft drinks which you can use, like you can choose Pepsi and Dr. Pepper and Orange, Mirinda, Dr. Pepper and Fanta. You can club and choose where they have implemented in US and Canada. So the company is facing a huge issue in optimizing the technical service agents, where the machine is going down on a frequent basis. They have launched for about 4,000 or 5,000 machines in US and Canada. So that machine has to be up and running for more than 85 to 90%, right? So that will become their break-even as well as give some profits for them. If they go below 80 to 85, then it's a loss for them to maintain this touch panel screens. So so that is the problem statement. So they find it very difficult to understand their favorite drink also. So in New York area, they have placed this machine. So in New York machine, people might be using 2 colas or 3 colas, three combined soft drinks, etc., where they want to find a favorite drink which is being supplied very frequently to those area and fastest moving or like top selling soft drinks, right, and high demand in that area, etc. So that is the issue, and they need more than 80% of the machine should be up and running. So the solution approach that we have is that one is a big. So we have this touch panel machines for about 4,000 to 5,000 machines, which we prepared a big data lake for each of the segments, and then each of the segments, meaning we classify it into broad categories: east, west, north, and south, and we prepared a big data lake and then built an analytics engine. Platform, it's a big analytics engine which they are trying to which we are trying to predict the maintenance of each of the machines, right? So I can say, so today we run an algorithm and say that every machine, like 60% machine will be will be up and running, and another 30% will not be up and running. So under which that I will say, if you have a subway, so this machine number 1, 2, 3, 4, 5 will be going down. So we need a technical service agents to be fixed immediately. So when the business is up and running, right? So I need 100 technicians to fix all the 30% of all the 30% to make it profitable, right? So that predictive algorithm which is being built and saying that I need 100 TSS will be needed today, and I need 50 which I needed to optimize, to say that to fix it, to fix those machines, etc. And in terms of supply chain, so once the nozzle data, so we keep tracking on each of the nozzle data. So once that 90% of nozzle data is getting over, automatically the message will send to the nearest supply chain person, where he will be addressing it immediately by filling the nozzle data with immediately, so that people or the customers from that region will not move ahead into a different soft drink different soft drinks. So so this is being optimized by using a IoT devices in the machine being fit on the touch panels. So so nozzle data being analyzed, and the heartbeat of each of the machines being increased from 78% to 95%. So this is the big program, or like big program that I have managed. It's a big analytics engine has been built for. I mean, this is just given a one gist of 3-4 points that I have given. It's a very big engagement. We have built an entire data science engine as well as a visualization engine for them to monitor this, as they are trying to compete with different beverages company. They have acquired around 95%. Now it's more to 98% of availability. It's a huge profit for this beverages company. Okay, good. So with this, I'm ending this topic of supervised and unsupervised learning. So I'm moving on to my journey, how I became a data scientist or data evangelist, right? So when I take a decision of like wanted to do a data science program, right? So during that time, I was having around between 10 to 11 years of experience in IT as a project manager in a tier 1 company. So then later I was analyzing through different tier 1 and tier 2 colleges which are very good. I mean, they have also just started during that time doing analytics programs. So, but what I feel is that Great Lakes have provided a very good mix of both domain statistics as well as computational, like computer science, and they have a good blend. I mean, as well as tools as well as like R, Python, SAS, Tableau, Google Analytics. All these tools have been taught in this Great Lakes program. So that interests me. So I compared with this course curriculum with tier 1 colleges, tier 1, any of the IIMs, etc. So I compared this Great Lakes program. They have provided a good blend of each and every topics that they have selected. Then after joining the course, I was committed and I was very focused in learning data science. So there were about a good crowd of people in my batch. There were around 70 to 75 people in the class. But we are so committed. So how did we learn is we made a batch learning. So one of our friends called Paul Arun. So so he is our head of I mean our batch. So he collated and grouped different set of people. So so during the courses that we will be in a batch, and then we will be learning statistics. I mean, statistics basically a little bit dry subject, but group learning will always help you to understand statistics in a very better way. So in our batch, there is a PhD in statistics also. So who helped us in arriving that, in helping each and every student in arriving that. Secondly, the capstone project in Great Lakes Institute of Management. So capstone is very, very key here. So capstone meaning a real-time project is being prepared by the students. So the real-time projects which will be given to the students, and the students will have to work towards the closure. That is one. So that helps most of them to migrate from data from other technologies to data science area. Because in our case, in my case, most of them have done a real-time project. So I did from the US company, so US manufacturing company. So they have provided a data, and we have done that project, which helps me to migrate from a different domain to data science domain. Also, I follow Kaggle, KD Networks, Data Science Central, Analytics Vidya, etc. So these are all the platforms where you can learn a lot, where they will be providing a good learning or knowledge platforms they do. So this is my journey. I hope this gives 1 hour is definitely not enough to learn everything, but this gives a very high level idea about machine learning and supervised and unsupervised.